Good day, everyone. We want to look at case 2 of this friction. And he's saying that if a body of mass M is under an applied force P, acting at an angle theta to the horizontal when it is at rest or just about to move. Now look at the body. Fr is acting opposite, this is a rough surface. Then P is acting at an angle theta to the horizontal. Now, he said resolving what? Horizontally. What do we have? To resolve horizontally, we want to have it as what? Here will not be what? P cos theta. Because it's inclined to the what? To the horizontal direction. Then along this side, you have what? P sin theta. So if that is what? P cos theta and P sin theta, then we are going to have it as what? What we have now is the reaction is going up, don't forget, and the weight downward. The weight is equal to what? Mg. Now, if you assume that the weight is equal to mg, which is mass times acceleration of gravity, then let's resolve horizontally. We want to have what? P cos theta. Now, because we are assuming the body is at rest or at equilibrium, we now say equal to what? Fr. Forward force equal to backward force. Now, what we want to do now next is what? Don't forget that P cos theta will now be equal to mu r. Let's call this one equation 1. Equation 2, we want to have it as what? Resolving what? Perpendicularly. Perpendicular. Resolving perpendicularly. What? Perpendicularly. That means vertically. Resolving vertically. So what we want to have is that we want to have the R equals to what? R equals to mg. R equals to, no, resolving it. Don't forget there are two vectors, two forces acting upward. One is acting like this, upward reaction, and there's another resolve one. No, when you resolve P now, along the vertical, it will be P sin theta. Resolving along the horizontal, P cos theta. So we resolve it, making two forces acting upward. This resolve part of P going up and the normal reaction. So we are going to have an R plus what? P sin theta equal to what? Mg. So this is weight. Now, let's call this one equation 2. Now, in the case of what? This, now that means we assume that the body is at rest or in equilibrium. Then we can now solve the two of them together. We can say that R is equals to what? Mg minus P sin theta. Solving what? 1 and 2 simultaneously. So when we solve 1 and 2 simultaneously, we are going to have a what? From equation 2, from 2, don't forget, if you make R resolve the formula, R will now give us what? Take this one there, now be what? Mg minus P sin theta. Therefore, we're going to have what? P cos theta equal to what? Mu what? Open bracket. In place of what? R, we will substitute what? Equation 3. Let's call this one 3 into the word equation. So we are substituting everything for R now, which is now what? Mg minus P sin theta. Now don't forget, if you open the bracket now, we have substituted the what? This equation 3, which was gotten from 2 into what? 1. Now, in this case now, okay, we substituted 2. This is 2. This is 1. Then we substituted 3 into 1. And we get 3 from 2. So 3 was gotten from 2. How? By making R the subject reaction, the subject of formula. Then what will I do? After getting R the subject of formula, by taking this P sin theta to cross the equal sign, we add P sin theta having minus sign, that mg minus p sine theta. Then substitute the entire word formula for what reaction in place of r in 1. We are going to have this. The open the bracket, we are going to have mu mg minus mu times we are going to have mu p sine theta. Then we have p cos theta. Now in this case now we can now have it as what? Bring down the we are going to have p cos theta plus mu p sine theta equal to what? Mu mg. So now what is common on both sides is p. In that case, we will have cos theta plus what? Mu sine theta equal to what? Mu mg. Therefore, p, if you are asked to find anything, we have done everything. Like they can ask you that to calculate p, you can get p in case you are not given as mu mg over what? Cos theta plus what? Mu sine theta. So this particular formula for what? Now let me show you a shortcut of it. If you are what? If this one is pulling above, if it's pulling below, you will have the minus sign here. So that means this particular thing, if it's pulling above, this is pulling above. So plus is for what? The sign for what? Pulling what? The applied what? Force. Apply force. Pulling above. But if the applied force is pulling below, minus sign can be what? Is what? The applied what? Is the applied force. Applied force pulling below. Pulling below. Now, if you don't see pulling above, you can say pushing above. If you don't see pulling below, you can also see pushing below. So pulling above is equivalent to what? Pushing above. Then pulling below is equivalent to what? Pushing below. Because so some questions they will tell you to find work done. After you have solved the what? The P, you will now have to calculate work done. Work done will now be equal to what? The force applied cos theta times distance. So they will not give you P. They will not give you this applied force. They will give friction. They will give you. They might not even give you. They will give you reaction. They will give you the angle. Give you mass. They will tell you to find. They will give you distance. You understand now? In case question like that come up, you are going to use what? You find your P first. Then the result P that will likely pull it forward is what? Because it must be a parallel force. Don't forget, work done is what? Must be parallel force times what? Distance, parallel distance. So in that case, the force that is parallel to the plane, to this rough surface is what? This one. So you now get that as your answer. So you can solve anything regarding this one based on what way. Then in the case of this, where the body what moves, if it moves, if the body of mass m moves, then that means that what? The net force, please take note of that. The net force now, that means that the net force will now be what? P cos theta minus Fr. Now, what I'm trying to say that if this body mass of mass m now move forward by this force applied at an angle theta, that means that this one is bigger than this. That is in the case of where what? P cos theta is greater than friction. So the net force becomes this. Then the work done will now be equal to what? The net force times what? Distance. Or the acceleration can be calculated as what? The net force over the mass of the what? Of the body. So we can calculate anything given to us. That is, I've looked at that case in a case where the body now moves forward, not the case of where the body is at rest. I'm talking about a case where if the body of what? Of mass m, that what? Moves forward. Mass m moves what? forward with the help of what? P cos theta, with the help of what? P cos theta. So because this P cos theta is, cannot use P sin theta, we always use the parallel force to the plane. So that is just that. So please take note of that. God bless you. I hope you enjoyed it. Thank you.